For the past several years, experts in science, technology, engineering, and mathematics have been working hard on NASA's Artemis 2 mission, the first time we'll fly to the moon in over half a century. Artemis 2 involves special collaboration with 4 other countries, and in this video we're focusing on Argentina. The Argentina National Space Activities Commission is sending a shoebox-sized satellite, known as a CubeSat, to hitch a ride aboard a ring that attaches the crewed ship, the Orion spacecraft, to the Space Launch System. From a deal announced a couple months ago, the CubeSat from Argentina is named Artemis. Now let's dive into the science behind what the Argentinian CubeSat is researching. Like the other 3 CubeSats, it will study space radiation. See our videos on the other CubeSats to learn more about that. But NASA says Artemis will also collect GPS data to help optimize future mission design and validate a long-range communications link. GPS, or the Global Positioning System, is a network of over 30 satellites that help determine the exact location of your smartphone and spacecrafts alike. You may be familiar with microwaves used to heat up your food, but microwaves, which travel at the speed of light, are also used in GPS by those satellites circling Earth. Compared with other electromagnetic radiation, microwaves have the second lowest frequency, or second longest wavelength, between about a millimeter and a meter. Most space communication also uses radio waves. GPS satellites rely on atomic clocks, which are so accurate they don't get off by second until at least once every 10 million years, and far longer for more advanced versions. These clocks work by giving a certain type of atom pulses at a certain frequency, usually cesium atoms and oscillations of releases from quartz. The atom's electrons need this precise frequency to jump energy levels, so when the oscillator's frequency gets too low, the electrons remain at a level too low. At this point, the clock detects the electric change and gives the oscillator another jolt, precisely enough to restore the proper oscillation rate. The satellites need to be this precise because they measure distances by the very short time it takes a signal to go between broadcaster and receiver. When a certain number of GPS satellites have timed the signal's journeys, we have enough information to pinpoint, with a method called trilateration, where the receiver is down on Earth, or in this case, up in space. We also have important technological infrastructure on the ground, including antennas and monitoring and control stations, to make sure all the satellites are working properly. NASA, and other space agencies like Argentina's, mainly use GPS and similar systems like the Near Space Network and the Deep Space Network to navigate and communicate. With Artemis' CubeSat data, we can learn more about all this and ultimately design better connected and controlled spacecrafts to explore our universe. The Argentinian CubeSat aboard Artemis 2 is a great example of how people in STEM fields are accomplishing amazing things, and NSTEM works to empower that expertise, and future generations will bring us safely to the moon and beyond. Contribute to this mission by starting a local NSTEM chapter or becoming an individual global member today.